Okay, we have got to do something about the planet's population of radio techs. There just aren't enough. This should not be on my bench. This radio came, no kidding, the whole way from Australia. People should not have to send their radios outside of the country they live in to get fixed. This is ridiculous. It's already cost this guy, whatever, I guess over $100 just to ship this radio to me. And then to make matters worse, if you live in the United States, you know all about, well, actually, probably if you live anywhere on the planet, you get stuff shipped to you from the United States, you know our shipping rates are just, wow, they're ridiculous. So it's going to cost this guy probably like 130 to 140 American dollars to get this thing shipped back to him. So he's going to have a couple $100 just in shipping. Man, we need some radio techs around the world. It's like I say, it's just ridiculous. So please note here, please repair the radio back to factory specs with the receiver and transmit alignment. Also, it currently has low transmit output on AM and sideband, as the finals do not appear to be working. Okay, so I have not plugged it in. I just got done unboxing it. So, and I'm not going to plug it in until I take it out of the cabinet. So, now one thing to remember with radios this vintage, especially in SBE, these use double-sided circuit boards. They're early, and it's not the manufacturer's fault. It's a problem all manufacturers had back in this day with those double-sided circuit boards. Consumer-level electronics. They're honestly just cheap. They do not use through-plated holes, and these radios. Well, like I say, anything that has actually double-sided boards. But these radios in particular, I've seen so many of these just horrible, just riddled with problems. And a lot of times, it's nothing but bad solder connections. Come on, little panel. Oh, where's my IC lifter? Got to take this back panel out here. It's actually separate from the rest of the wood. If you don't take this out... There we go. Can't get the radio chassis out. Okay, there's that. Now we got to get the 4 screws along the sides. But anyhow, like I say, they're just known for having so many cold solder joint problems because of the, and you'll see that, like I said, a lot of radios. Johnson's, I mean, good Lord, the list just goes on and on. Any manufacturer that had a double-sided circuit board, you're guaranteed they had radios that had very similar problems. And the reason is, like I say, the boards do not use through-plated holes. They just have circuit traces on both sides of the board. And then they interconnect them with little jumper wires from one side to the other. Actually, kind of look like a nail, I guess you could say, with, has a head, but they're made out of copper, not steel, obviously. But they just break loose. And gently get this cover removed. Okay, and yes, this is one of those radios that it's upside down. When the radio's right side up, the chassis is upside down. Let me get these TMP cables are getting wrapped up in there. Get this cover off. So for starters, looks like the electrolytic cap there at least is original. And the one's on the power supply board over there, so it doesn't look like it's been recapped yet. So it's definitely overdue for that. And does this have a channel mod? I'm not sure about that yellow wire right there. Actually, that looks like it might be... I don't know. I'm going to have to look at that. Been a while since I had an SBE Console V opened. Yeah, we're going to have to check on that. But yeah, it's got the normal bodge parts. Now, actually, that cap looks new. That does not look like an original cap. Yeah, it's a Nichicon, looks like. So maybe this has been recapped. I do see what looks to be lots of shiny solder joints all over the place. And oh my god, what is up with those ground wires right there? Look at that glob. Come on, focus. There's a heck of a mountain of solder right there. Yeah, looks like this may have been recapped, but for some reason they recapped it, but they didn't replace the main filter cap or those two caps on the power supply board. Don't know. So let's take off the bottom cover, and what is that? Looks like a piece of paper hiding down in there. Let's just barely make it by the camera. Okay. Now to get the bottom cover off, there's a couple screws along the back side that screw into the flange there, and then it just interlocks right there, picks up and lifts out. I do believe this is an extremely low serial number radio. Get this last screw out here, but okay, and you can see how that ear just fits up under there. And yes, there is a piece of that the build sheet. I don't think I've ever seen one of these in a radio. Oh my god. I've worked on a lot of SBE Console Vs. I have never seen one of these. This is interesting. How cool is that? The original check sheet. You know, transmit, RX. RF gain. Yeah, it's kind of written in Japanese and English, because that looks like English, RF gain. But yeah, the rest of that I'm assuming is Japanese, because these were, I'm pretty sure they were made in Japan. Yeah, made in Japan right there. So yeah, how cool is that? The original build sheet and the checkout sheet or card from when it was made. Definitely want to keep that with the radio. Now, as I was saying, low number. Look at that, 000196. So yep, looks like we got unit number 196 here. So that definitely is a low number. Okay, so looks like the filter cap has been replaced. Main power supply filter cap. There's a capacitor bodged on the bottom side here, so that's effectively been replaced. It's been terminals cut off there, and then this cap just installed in its place. I think those two on that board are still original. So yeah, it looks like all the rest of the caps here, these have all been replaced. So nothing wrong there. Now, the problems these radios have. The pass-throughs. So let's try to get zoomed into some. Let's see, where am I at in the camera here? There we are. So you can see, like, anywhere you see a little silver dot on this side of the board, that's a pass-through. There's a little connector jumper that connects a trace, you know, like in this case, that trace right there connects it to a trace on the bottom side of the board. And inevitably, they always fail on this side of the board. And that's extremely hard to try and troubleshoot and find and repair, because you can see a lot of times they're trapped down in between stuff. They're everywhere. They're just little all over this board. You know, this one's trapped in between these two transformers here. Trying to get down into these things can be it's a feat. So, but it doesn't look too bad. Looks like someone also replaced the mica insulating washers. I'm not sure. Those seem awfully darn rubbery. Yeah, I don't like those. See that? How that's disintegrating? Yeah, I'm going to replace those. I don't like this style pad just because of that. They're fragile. And like here you can see on this one, you see how deformed that is? over time, because it's like that, because it so easily breaks and kind of pulls apart, when a screw's tightened down here, now it has an insulating washer on the top, but this is not only, you know, insulating this from this, it's, you know, it's transferring, the insulating heat transfer pad, but you can see it's deformed, so that means there's a lot of stress on this rubber. So over time what can happen, and I've seen it happen with this style pad, is it'll split, and then this tab is going to short out against the steel chassis, and poof, you know, this part will go up in in a puff of magic smoke. Or what do we have going there? Why does it look like that coil has... what the... Anybody else noticing that? That doesn't look too good, does it? It looks like either it got hit with a soldering iron, or it actually looks like it just plain overheated, because the whole side of it's just warped. Yeah, I'm gonna have to check that. So that inductor looks like it might have vaporized internally. So I'll have to check and see exactly what the heck's going on. And if that's part of the power regulation circuit, that might be his problem for output power. The thing is, that's in the, looks like it's probably part of the audio circuit. I got to get the schematic out and check, but yeah, we're in the audio circuit. The audio amplifier's right there. You can see it down there. But still, yeah, that's the first obvious thing. There's definitely a problem there. That's it shouldn't be all deformed like that. But otherwise, doesn't look too bad. Can't say I see any cores that look like they're broken. Get zoomed back out here. Oh, come on. Little tabs weren't bent back over. When you take the covers off to get this module out, there's 4 little ears. Normally these ears are bent over like that. Those ears are bent over so the board can't come up and come in contact with this. I mean, it does have little foam blocks on here, but you know, they disintegrate. That just helps, kind of like a safety thing. Just make sure before you put the covers back, don't always bend those little ears over. Like I said, it just kind of helps keep the board in there. And this was not recapped. That is an original electrolytic capacitor, so yeah, the PLL, yeah, and there's 2, 3 more caps down in there. They weren't replaced, so we'll have to get those. Take out our oscillator can cover here. Yeah, that one was changed, so looked like they got most of the caps. So let me go grab a schematic now, go get the Sam's manual on this, and I'll pull out the factory service manual, see exactly what the heck this this nuked, just out of view, this nuked inductor down here is. Yeah, from the top you can really see, looking at it straight down, how it's kind of egg-shaped. And see if that might be part of our problem. And we'll go through her and see about getting this thing fixed up for this guy. Like I say, man, just such a shame that somebody has to ship something like this, as heavy as this, a base station radio, all the way from Australia to the United States to get fixed. I just can't believe there's not somebody in Australia that's competent enough to work on an SBE Console V. That just, mind blown. I just, wow. And this isn't the first time. I've had other radios from Australia before, and other countries, and just every time I'm just mind blown. It can't be, is all I keep saying to myself. So I'll be back. Let's see what we can find. Okay, so I've not gotten the service manual out yet. I actually, once I got the camera swung out of the way, just started looking over the board a little bit more, and yeah, we definitely have some problems in the RF section of this thing. I don't need a schematic to see this. So someone has definitely been in here. I mean, obviously it's been recapped, but what's the first thing you notice when you look straight down at this? Okay, this one looks fine. Where are we at in the picture here? Okay, so we got a nut, there's the insulating washer, there's the tab of the transistor, and there's our little insulating pad, and then the heat sink. But everything's nice and tight. You come over here to this transistor. Why is there a gap See that? There's the tab, and you can see daylight down in between that insulating washer. So that means the insulating washer is not, it's a step washer, okay? That's meant so the plastic on the step of that washer fits inside the this tab, so the screw can't touch the inside edge of the hole of this tab, so it doesn't short out. And then if you look down, I don't know how well that shows. I don't know if I can get any zoomed in anymore. And it might look fine on, yeah, and again, I'm looking at a tiny little screen on this camera. It's broken off. See that crack? It looks like the transistor's split in half. So, yeah, there's something seriously not good down there. So, yeah, first thing I need to do is, I'll just grab, actually we can just do that really quick on camera. Let's just flip this over, because of course all these solder connections are on the top side here. Turn on a meter over here. We'll just do some really quick continuity tests. I just want to see if the transistor is completely shorted out to ground or not. Get my leads untangled here. Okay, get that clipped on there. Ohm meter. What do we got? Doesn't look like it's shorted to ground. That looks fine, and I can't really get in to this one very well. It seems awfully low there. I also want to check, just slide the camera out of the way, trying to get my head down in here. I think we got a problem over here. Yeah, we definitely have a problem in the power regulation circuit throughout this radio. All these resistance readings are just way too low. Yeah, I mean, I got like ground potential on one terminal, 15 ohms on another. Over here they're in the like 20s. So yeah, we got some serious problems here. And I got to clean up some of this solder because it's kind of hard to, just kind of goopy, and yeah, I mean, it's kind of hard to tell with the reflection, but yeah, it just, all the flux residue and whatnot, it's kind of hard to see. I mean, just look how crunchy some of this stuff looks here. Yeah, I need to go through, clean up the solder. Heck, it's the PLL module on the bottom side flopping around. I need to clean up some of these solder joints. I'm going to pull that inductor, pull both of these transistors. Probably going to pull both the driver and the final. I'll probably even pull the pre-driver, because honestly it looks like that's also been tinkered with. You can see by the goopy solder work on that pre-driver. Is that even, get that out of camera view, I'll get my head down in here. Nah, didn't know if that looked like it might have been shorted together. It's not. But yeah, I'll probably just pull everything in this RF section. It's just a couple solder joints. I mean, other than I got to take this little ground tab up so I can test these, pull those other transistors, because yeah, there's some dead shorts in here. And that's, guarantee that's why that coil on the top side, that one that's in the plastic housing, tried to vaporize. If it hasn't actually already gone open, that's why. It's because there's a short somewhere in here. So yeah, got my work cut out for me. So nothing new. So I'll be back. Okay, so she's pretty much... Figures. As soon as I start to say something, somebody comes on. Pretty much done, with the exception I just need to pop the knobs off of this, clean the knobs, clean the faceplate up a little bit, which it doesn't really need much cleaning, and put the cabinet back on it. Basically, I'd have to say 90% of the problems with this thing, and maybe 100%, were all related to soldering issues. There was a short that caused this. So if you remember this little guy, this coil that kind of looks like it went nuclear, it got way too hot. This has been replaced, obviously. I have it in my hand, the original. This is actually in series along with a 220 ohm resistor that's parallel across it, but it's in series from the output of the AM modulation transistor to the drivers and the finals. This got shorted out. There was a couple connections on another, solder pad behind it that has a wire that comes down to it. Looks like someone had reflowed that and the wire moved and it came over and shorted out against one of the leads. Well, yeah, that's smoke time. So yeah, that's why this little guy went. So I went ahead and actually replaced that regulator as well. I replaced the final and driver because even after I did that, the output power was just deplorable. The driver looks like it was working okay. The final was bad, so that's why it got replaced. I replaced the driver because that was the one, let's see, where is it? That's laying, yeah, that's this one. If you remember, I said how when we looked at it down from the top, it looked like it was cracked. Well, yeah, it's bent. I don't know what the heck happened to this poor thing, but there's a crack running down each side from the tab. I don't want to take a chance, because you have to remember, this thing traveled to the United States all the way from Australia at a price of, actually I had cut it off of the box. There's the original shipping, the postage off of the original box. It cost this guy $131.08. Now it's Australian dollars to ship this thing here. Now that's probably, I don't have, it's been so long since I converted Australian to American dollars, but I think that's around what, maybe 100 US dollars. And when I ship this back, it's going to cost probably 130 to 140 American dollars to send it back. So he's going to have 200 to 250, I don't know, probably somewhere around that, just in shipping this here and back. I'm not going to leave this little thing in there and have the chance of it going poof. So yeah, it's just cheap insurance. I replaced all of these pads. And this is a good example of why I don't like these original ones, and you have to be careful. Now, I use the silicon insulation pads. There's absolutely nothing wrong with them if you get the correct ones. I know a lot of people say, oh, they won't use these. The only thing they'll use is a mica wafer or a ceramic insulator. They won't use these because they say, oh, well, they can fail. And this is a good example of one that can fail. You see that? Now, before I just pulled on it, there was a cut right along the top edge there, and that was the edge of the transistor. A lot of times they'll have a burr, you just grab one, they'll have a burr on this back edge because these are stamped out. There's a big stamping die, a big sheet of tin-plated copper, and just the machine comes along, ka-chunka, chunka, chunka, and punches them out. It's a punch die. Well, can be a burr on the back side. That burr cuts through these because these are just so spongy and so flexible, and there's no reinforcement in them. Where just grab one. If you get the good high quality ones, like these, I don't know how well, if at all, it will show up, but this one actually has fibers in it. If you look at it, it looks like a piece of cloth that's been impregnated with that silicon material. I can't rip this thing. I pulled on this thing as hard as I want. You just cannot rip through these things. These are extremely heavy duty. And you get these from any of the good suppliers, DigiKey, Mauser, pick your poison on electronic suppliers, but get the good ones. Don't buy bulk lots of 1,000 of them from China. You're going to end up with some piece of junk like that. So, like I say, I replaced all of those. Other than that, really, like I say, replaced the coil. I did replace one green poly-dip cap in this radio. A lot of radios back in the day, not just SBE, can be, you name the manufacturer. I've seen them in lots of manufacturers' radios. Occasionally you'll find some of them, they have green poly dips that were made by a company, I guess the company's name was Silk, S-I-L-K. And every time you see a capacitor that says Silk on it, you can be guaranteed it's falling apart. This one is no different. Now, it hasn't gotten really bad yet. I gotta find it. Right there on this back edge, there's a crack in the poly coating on this thing. Okay? And it's just a matter of time before this thing starts to disintegrate and all that green stuff will just flake off of it. Well, it's exposed to the atmosphere now. Moisture can get into the aluminum, it'll oxidize, cause problems. So cheap insurance. If you ever get a radio and it has these Silk capacitors, and you'll see, now this one hadn't gotten to that point, it's starting to get rough, but you'll see these over time, they actually get a white crystalline fuzzy looking stuff on here as this green stuff, the only thing I can figure is it decomposes. It's breaking back down into its original constituent parts. But yeah, just do yourself a favor, you ever see Silk brand capacitors, just go ahead and change them because they're failing. Pretty much guaranteed. I've never seen one of these things in the last God knows how many years that wasn't split, if not just pieces of it just falling off, just completely disintegrating. Other than that, needed an alignment, and radio works fine now. After I actually got the driver and the final transistor into it, I still had really, really low output power. I think that was probably because somebody tried to align this, or they tried screwdrivering it, you know, half-assed alignment, I guess you could say, to try and get the output power up. There was a problem, so that's why they couldn't get the output power any higher than it was. It was, you know, probably 1/8 of a watt or less. So yeah, that was just a matter of did an alignment. Receive sensitivity is really good, as you would expect. Now, unfortunately, I don't think there's... Yeah, there's really nothing on sideband. Just bad time of day. About the only thing coming in is channel 6. The big boomers. But, you know, if you're going to have a company, SBE stands for Sideband Engineers. You know, if you're going to have a company called Sideband Engineers, you better make halfway decent sideband radios. They do. These are really good receivers, have good crystal filters in them, really well designed receivers. Transmit's actually very good on these as well. One of the things that helps with that is these do have speech compression built into them, so there's a little circuit board located right about here on the undersides. But actually, I even have a bunch of spares. Let me see if I can find them really quick. What drawer are they in? SBE. I got a whole drawer of the blasted thing somewhere. Izu. FM modulator boards. Oh, I've got too many parts. There we go. SBE Console V speech compression modules. These things. I got a whole box full of these. Got them in an auction one time. I don't know why. Somebody had took them out of radios or just parted out radios. I don't know, but I ended up with them. And I got them. I mean, the reason I wanted them is because they work really well. But this is the board that's in this radio. And if you align this little board properly, your transmit audio, you're going to have really good transmit audio. Now, alignment on this it's kind of strange the way they do it on these. It's actually aligned in receive. Now, this circuit has nothing to do with receive. This is the microphone compression circuit, but you actually align this or do adjustments on the two trimmer potentiometers on this while the radio is in receive. What you do is you pipe in a 10 millivolt 1000 hertz audio tone into the mic jack. You attach an oscilloscope probe to... Oh, actually, this is a variant of it. There's a capacitor missing on this one. There's an electrolytic cap right that would normally be right there. But that diode that's down in there, you attach a scope to that, and you adjust the compression gain control right here, this trimmer resistor, for maximum amplitude with minimum distortion. So you're just going to see your 1000 hertz sine wave on your oscilloscope, and you're adjusting for that clean 1000 hertz signal, and as soon as you start to see it clipping, back it off a little bit. You're done with that adjustment. Then you check at the output. Actually, the service manual has you test down on the circuit board where the coax cable comes out and back down to the board, and you test for a 40 millivolt signal there by adjusting the compression level. So you adjust the compression level for 40 millivolts basically at the output down in the radio where it reattaches, and that's it. But it's like I say, it's actually done in receive, and properly adjusted it works really well. And that, to give you an idea, you're putting 10 millivolts into this and you're getting 40 millivolts out. So it's also, you know, obviously it's an amplifier circuit. But they work really well. And like I say, really makes the transmit audio on these. It gives it a little bit of extra punch. So there you go. There's a SBE Console V. Sorry there's nothing really on air to listen to. Just kind of always seems to work out that way. Yeah, even 6 is dying. Oh, another thing, these do have very good, actually, turn the noise limiter off there. See? They have really good, that's another thing SBEs were known for. Very good noise limiters, noise blanker, I just leave that off. And actually, speaking of noise blankers, that's something I think some people get confused about. A radio like this is a perfect example. Turn the volume up, they flip it and they say, I don't hear anything. Well, you're not going to. If you flip the noise limiter, yes, there is an obvious difference. You're not going to hear a difference with the noise blanker. The noise blanker operates on impulse noise, and that's actually how you, and this has actually a very, that's one thing that's really, really, I'd have to say, one of the best noise blankers of any CB radios are SBEs. SBE really put a lot of engineering into their noise blanker circuits. There's, what, 4, 1, 2, 3, I'm just trying to think here out loud, 1, 2, 3, 4, yeah, there's 4 tunable transformers in the noise blanker circuit. And it's very, very effective if it's aligned properly. A noise blanker doesn't do anything for that, the sizzling bacon. Does nothing for the sizzling bacon. That is noise. The noise blanker blanks out impulse noise. It's mainly, you can think of that as like ignition noise. It's a really sharp, it's a pulse of energy that happens with a really fast rise time and collapses and goes away. It's just a spike. If you look at it on an oscilloscope, that's actually what you do. You attach your oscilloscope to the test point in there, you inject a pulse, and it varies from manufacturer to manufacturer, but they'll give you a pulse duration and amplitude. You inject that into the radio, and what you're doing is adjusting the noise blanker circuit for the maximum pulses you'll see on your oscilloscope screen. But that's what the noise blanker does. It blanks out those pulses. What it does is it actually mutes the audio for a tiny fraction of a second while that pulse is occurring. Now, it happens so fast to the human ear, you never notice that the speaker got shut off and turned back on. But if you're in a car that has really noisy ignition system, or anything else that's causing an impulse type noise, you know, repetitive pulsing noise, that's what the noise blanker does. So on a normal, just staticky day, that, you're not going to notice any difference at all when you turn a noise blanker on and off. You'll notice a difference with the noise limiter. The noise blanker is for impulse noise, the noise limiter is basically for everything else. And that's why you get such a big difference when you flip your noise limiter on, but most people never notice a difference with the noise blanker. That's really only used for impulse type noise. So, you know, if somebody's driving past your house and has a, you know, solid conductor spark plug wires, they're driving a race car, let's say, the noise blanker would blank out those noise, or not that one, this one. The noise blanker would block out that ignition noise, because that's what its job's for. Really sharp, fast, repetitive spikes of RF energy. So, in any case, I thought I'd just really quick cover that, because that is a question I get occasionally, and I just had some time ago with somebody asking me about a noise blanker. He said, I flip it and I don't hear any difference. Well, unless you've got a noisy car with a, you know, leaky ignition system sitting beside you, you're not really going to notice a difference when you turn your noise blanker on. So, but there you go, SBE Console 6. Like I say, final cleanup, put it in the cabinet, and be ready to ship back overseas to Australia.